Fortran. Classifier language. Fortran is an imperative and procedural programming language. It follows a procedural paradigm where the program consists of the sequence of statements that are executed in order. Fortran is traditionally known for its use in scientific and engineering applications, with its focus of procedural programming. This is question 6 for Fortran. What kinds of selective statements are supported? If and switches. Are they all equivalent? How do they differ? How are they alike? By writing code in each syntactic possibilities. For Fortran, we do have both. We have both an if and a switch. It's not really called a switch here. It's called a select case. It's basically the same thing. It just has a different name. For our if, Fortran differs from other languages and in that it uses parentheses. This is kind of common in Java or C++. It also differs in that it uses a then to follow its code. To send it to its next input. Another thing that's kind of unique for this language is that indentations don't matter. You don't have parentheses for the block of code that you're going to execute. It just follows the keywords. As you can see here, this program is pretty simple. It just checks whether a number is even or odd. For example, here 12, it's even. It's simple. Here's the syntax for it. And next are the switch or select case. For this one, it's the same, but it also has some unique features that are only in, or not only in Fortran, but they are not in Python. One of them is for the case if nothing is in the statement that you're going to execute, it just stops. In other programming languages, this might send you to the next line of code. So if it was a case 0, it would go here. But in this case, it doesn't. It just stops. Let me show you this example. Yeah, it just goes to the next line of code, which was a goodbye. Also, it has this cool feature where if you put a colon between two numbers, it gives you the range instead of having to put every single number, like I did here. Here it gives you the range from 8 to 10, which is just 8, 9, 10. But I also thought that was pretty cool. And 9 isn't prime. Lastly, the switches here does have a default case. So for example, if something is entered that isn't in the cases, it will default. Let me show that real quick. Yep, it goes straight to the default. And this is syntax for it. This portion is for questions 8 and 9. What kinds of iterations are supported? For example, for, while, repeat until, do, for each, etc. Are they all equivalent? Explain how they differ. How are they alike by writing code? Okay, for this one, Fortran only uses do and do while. As you can see here, the implementation for do is pretty simple. It's just a do and an undo on the bottom when you stop using that. Another thing you can notice here, it's kind of like a for loop in C++ where you declare an n and then it goes to that range, as you can see when it runs. Yeah, it'd be this first one. It follows the n. It's just iterating on its own. I don't have an iterator for it. It's doing it. The only thing I'm actually doing is in fact. It's doing the square. And also the do while. Here it is. It's the same thing. It's pretty simple. It's just do, a while, and the condition. Here's its output. They're pretty basic. And for question 9, is it possible to exit from any of these iterative constructs before the neutral end is reached? If so, how? This is possible. you just have to use the keyword exit. It's the same thing for both do and do while. In this example, I'm just going to use it for the do, but it's the same application. As you can see here, if the n fact is equal to 49, which would be the square root of 7, it's just going to stop. And if we run it, you can see here, using exit in a do loop, it exited at 7 squared, which is where I wanted it to, and it just continues on. Fortran also has another two features, which are cycle and stop. For cycle, it skips the step in the cycle. So for this one, when it runs, it's going to skip the 8, and for this one, when it runs, it's going to stop completely the program. That's the reason I have it 250. If I use 5, you're going to see that this do while is not going to run anymore. Yeah, it just stops here where it's supposed to be 5. In the cycle, skip the 8. This is for question 10. Question 10 asks, are there limits for arithmetic computation, such as a minimal and a maximal integer? What happens if you perform computations that cause an overflow? Explain what kinds of numbers are built in and what limitations they have with regards to precision and how they are stored. For this, it's pretty simple. Fortran has a pretty cool feature where if you put huge and the type of variable, as you can see here, when I run this, it's going to print integers because it doesn't have a point like this. This would be a real number, and this one would be a hexadecimal number. So it gives you the biggest number that could be, and if you run tiny, it gives you the smallest number it could be. In the case of integers, we just have to get the negative of huge, because the biggest number is also the smallest number you can get. So let me run it real quick before I do that. Okay. Here you can see the biggest number. It's this really big number, and the smallest it could be is this. So it would be in the negatives. And it's the same thing for this. This is the biggest real number, and this is the smallest real number. And this is the same thing for hexadecimal, I believe. Alright, and in the case of what happens if you cause an overflow, we can do this pretty simply with, I assigned x here to huge. Wait, no, I did not assign it. Oh yeah, I did. I assigned x to huge, and if we add 1 to that variable, we were going to go over what Fortran allows, so we can see what happens. Here it is. We can see that it went to a negative number. It's technically correct, but it's negative, so that does show us that an overflow happened. It's kind of weird that it has no protections against it. It just lets it happen. But yeah, that's how we can tell. This is question 11. What kinds of operators are supported? Unary, binary, ternary. How are the arithmetic expressions implemented? Are they infix, prefix, or postfix? And what are the operator precedence rules? What are the operator associativity rules? And what is the order of operand evaluations? First, we can see here that we are allowed integers, reals, and logical numbers, so like bools. Here's a quick association. Here are the unary operators. Okay, let me run that real quick. For the unary operators, they do as they say. Minus a would be minus 5. That's what we get. For the real one, that'd be minus z is equal to negative x. Negative x is equal to 0.2. So that's what we get. And for the bool operator, p is equal to true. And if you do not p, you get q, which is not F, which is false. Alright, and for binary operators, here we can see that our expressions are infix, as the token operator is in the middle instead of being off to the side. Okay, let me run this real quick. It's right here. Alright, before I go over the results, let me explain first the precedence. Before anything, we have exponential numbers, so exponents, then unary operators, multiplication, division, and the power. These have the same rank, and then comes addition, and then contradiction. Okay, okay, for addition, here, we reassigned C. Now it's 8 plus B. That's 3 plus 5. We get the 8. Then we get X times Y, which is 2 times 1.5, and that's how we get our 3. And lastly, we check if A, which is 5, is greater than B, is 3. So P is equal to T, which is true. And that would be it.